When optimization quietly removed freedom, it felt like improvement. Faster systems, cleaner outcomes, fewer choices to worry about. Optimization promised relief, not restriction. Every step forward looked like progress, and no single step ever looked like a loss. That is what made the process so effective and so difficult to see. To understand why this matters today, we need to look at how optimization works in chemistry. When a reaction pathway proves more efficient, it becomes favored. Resources flow toward it. Alternatives are labeled wasteful. Over time, chemistry narrows the field to what performs best under selected metrics. The narrowing is not arbitrary. It follows logic, rewards performance, and delivers measurable gains. But what it measures and what it discards are never given equal scrutiny. At first, this narrowing feels rational. Fewer variables mean fewer failures. Optimized reactions reduce cost, increase yield, and simplify planning. Freedom appears intact because the best option is obvious. When the choice is between an efficient pathway and a slower, costlier one, the decision makes itself. No one has to be forced. The numbers do the work. But optimization changes incentives. Systems stop asking what is possible and start asking what is optimal. Chemistry begins selecting pathways not because they are the only ones available, but because everything else is discouraged. The shift in framing is subtle but transformative. Possibility is an open field. Optimality is a single point. Moving from one to the other feels like sharpening focus, but it is also a contraction of vision. As optimization spreads, infrastructure adapts. Equipment is designed for the preferred reaction. Training focuses on maintaining it. Regulations assume it. Chemistry becomes embedded not as one option, but as the standard. The standard then shapes everything that follows: budgets, timelines, career paths, safety protocols, until the distinction between the optimized pathway and the only pathway dissolves entirely. This is where the shift begins. Freedom does not vanish dramatically, it erodes quietly. Alternatives remain technically possible, but practically unreachable. Choosing differently becomes expensive, slow, or risky. The barriers are not walls, they are gradients, gentle enough to feel natural, but steep enough to prevent movement. What makes this process dangerous is subtlety. Optimization feels like progress. Each step improves performance. Each decision appears reasonable. Chemistry rewards efficiency without signaling what is being lost in the process. The losses are not tracked because no metric captures them. Freedom, adaptability, and optionality do not appear on performance dashboards, and what is not measured is eventually forgotten. This is where the story begins, with optimization doing exactly what it was designed to do, while quietly removing the freedom to choose differently long before anyone notices a choice has disappeared. As optimization deepened, chemistry began shaping behavior more than intention. Systems aligned around the most efficient pathway because deviating from it felt irresponsible. Efficiency became a moral standard, not just a technical one. Choosing a less efficient option, even for sound strategic reasons, carried the weight of seeming careless or wasteful. The pressure to conform came not from authority, but from the logic of the system itself. This is where early tension emerged. Optimized reactions tolerated little variation. Inputs had to be precise. Conditions had to remain narrow. Chemistry delivered peak performance, but only inside carefully maintained boundaries. The performance was real, but so was its fragility. The system could do one thing superbly and almost nothing else at all. Alternatives slowly lost support. Infrastructure no longer fit them. Expertise faded, even imagination narrowed. Choosing a different reaction was still possible on paper, but rarely in practice. The practical barriers accumulated quietly. Retooling costs, retraining timelines, regulatory misalignment, until the sum of small inconveniences became an impassable obstacle. What made this shift dangerous was invisibility. No rule forbade alternatives. No authority banned them. Optimization simply made them inconvenient. Chemistry rewarded conformity quietly and consistently. The constraint was never imposed. It emerged as naturally and inevitably as water finding the lowest point. Over time, the optimized pathway began defining success itself. Metrics were built around it. Goals were set assuming it. Outcomes were judged by how closely they matched its behavior. Freedom remained in theory, but not in action. The system could not recognize the absence of freedom because every measure of health was calibrated to the optimized state, and by those measures, everything looked exactly as it should. Scientists noticed the pattern too late. Chemistry had not eliminated options. It had priced them out of reach. Every improvement increased dependence, making divergence harder with each cycle. The cost of switching was not constant. It grew with every year of commitment, every piece of infrastructure aligned, every generation of expertise trained exclusively in the dominant pathway. Optimization had done its job perfectly. It reduced waste, increased output, and simplified systems. But in doing so, it also removed slack. And slack is where freedom lives. The margins, the redundancies, the seemingly wasteful alternatives that no one needed until the day everyone needed them at once. These were the first casualties of optimization, and their absence was felt only when it was too late to recover them quickly. The system felt efficient, but it was also increasingly fragile. Chemistry had not taken freedom away, it had optimized it out of existence. The conflict intensified when conditions shifted beyond what optimization could tolerate. Systems built for peak efficiency struggled when reality introduced variation. Chemistry that performed flawlessly under ideal conditions reacted sharply to deviation. The precision that defined the system's strength became the source of its vulnerability the moment conditions moved outside the narrow band it was designed for. Small disruptions produced large consequences. Supply interruptions cascaded, minor impurities amplified effects. Optimized reactions lacked buffers because buffers had been labeled inefficient and removed. Every element of resilience that had once existed as a natural byproduct of diversity had been systematically stripped away in the name of performance. This buildup carried emotional weight because the loss was no longer abstract. Freedom had practical value. It allowed adaptation. It absorbed surprise. Optimization had stripped those qualities away in exchange for performance. The trade had been made incrementally, invisibly, and without consent, and the full cost was visible only in the moment when the system needed what it no longer had. Attempts to restore flexibility proved difficult. Reintroducing alternatives required rebuilding infrastructure, retraining expertise, and accepting lower efficiency. The cost of choice had become visible only after it was lost. Restoration demanded the very resources that optimization had redirected, and no one had preserved a path back. Chemistry revealed a harsh truth. Efficiency maximizes output only under assumptions that reality rarely honors. When those assumptions fail, optimized systems have nowhere to go. The reaction does not adapt. It breaks, because adaptation requires the kind of flexibility that optimization specifically and deliberately eliminated. This was the emotional peak, the realization that freedom is not waste, it is capacity. And chemistry, when optimized too narrowly, can eliminate that capacity without ever announcing the trade. The system did not feel the loss until it needed what was gone. The system had not been forced into fragility, it had been optimized into it, one reasonable decision at a time. The climax arrives with a realization that reframes everything. Freedom was never removed by force. It was traded away for performance. Chemistry did exactly what optimization demanded. It selected the fastest, cheapest, most consistent pathway and rewarded commitment to it. What it did not protect was optionality. That was left behind quietly, one improvement at a time. The chemistry was faithful. The framework that directed it was incomplete. This understanding reshapes responsibility. Optimization is not neutral. Every metric chosen excludes others. When chemistry is optimized only for efficiency, it will sacrifice resilience, adaptability, and choice without hesitation. The sacrifice is not malicious. It is mechanical. It is what optimization does when its instructions are too narrow. The resolution lies in redefining success, allowing inefficiency where it preserves flexibility, maintaining parallel pathways even when one performs better. Chemistry becomes supportive again when it serves values instead of replacing them. The discipline required is not technical but philosophical, the willingness to protect what cannot be measured alongside what can. This story is not a rejection of optimization. It is a warning against worshiping it. Efficiency should be a tool, not a destination. Progress measured only by performance eventually narrows the future it is meant to improve. Freedom in chemistry looks like slack, redundancy, Alternatives kept alive on purpose. They appear wasteful until the moment they are needed most. Understanding how optimization quietly removed freedom gives us a chance to restore it, not by undoing progress, but by choosing to protect choice before chemistry optimizes it away again. Subscribe to join the journey. When